So we saw that functional programming is what's common to the new features of Angular through the Angular Renaissance. In this lecture, we're going to talk about object-oriented programming and functional programming, how they're different from each other, and we'll discuss why Angular is starting to use more functional programming. So let's start by considering an example. So in this example, we need to create something that calculates the value of a sale, and we want to allow different types of discounts. In object-oriented programming, we do this by something called polymorphism. So you see that the sales processor contains a method that calculates the discount. It does that by accepting an iDiscountPolicy object. Since iDiscountPolicy is an interface, it means that there are different implementations and they all have in common the calculate discount method. So the sales processor accepts the discount policy and the sale, and it calculates the discount and returns the amount with the discount deducted. Now, as you can see, in this example, we have two different implementations of discount policies. One of them is loyalty discount, which calculates the amount of discount according to the customer type. Another one is a seasonal discount, which calculates the amount according to the amount of sale. So everything above 100 deserves a 15 discount. Now, we can see that if we want to use the two different types of discounts, then for each one of them, we actually need to create an instance and then send it to the sale processor. Now, there seems to be a lot of work here. First of all, we need to create a new class for every discount. The only thing that's different between two discounts is one line, but we wrap it with a lot of code. And also, when we call the sales processor, we need to actually create an instance of discount. Now, the instance doesn't make any sense because there's no state, there's no reason to create an object just so we can send different logics to the same function. With functional programming, the same example looks a lot skinnier. Okay, the discount policy type is no longer an interface, it's just a type of function. And the sale processor accepts a function as parameter. We can see that the two discounts are just functions. We don't need to invent new classes. We don't need to wrap anything. The only thing we supply here is just a line of code. And what we pass to the sale processor is a variable that points to specific functionality, to a line of code, to a function. And that's the difference between doing the same thing with object-oriented and with functional. In functional programming, we can simply pass functions as parameters. We don't need to wrap them with an object, and we don't need to define a class just so we can instantiate the object. So functional programming is really good for event-driven code, for asynchronous operations, for data transformations. For example, in event-driven systems, functional programming lets you use function pointers instead of creating lots of classes and interfaces for each event. For asynchronous code, functional programming makes it easier to chain different steps together by using pure functions without side effects. When we need to transform data, tools like array map, filter, or reduce help us manipulate data collections easily. The key idea is that functional programming allows us to put small, simple functions together to create bigger solutions, making the code easier to reuse and maintain. Now, when we think about object-oriented, everything is an object. Okay? Numbers are objects. Booleans are objects. Objects are instantiated from classes, and the classes include state and methods. Methods contain the logic that might mutate the state. So you create an object, you call the methods, each method may mutate the state, and basically your entire code revolves around these objects. Methods always belong to classes. Okay, they're different than functions because functions are independent and methods are a part of an object. Variables in object-oriented programming always hold objects, and methods receive and return objects. In functional programming, functions are first-class values. So that means that variables can actually hold functions. Functions can receive functions as parameters. And this is what we call higher-order functions. Higher-order functions are functions that either receive or return functions. Now, in functional programming, there are three more terms that we're going to talk about it as well. One of them is pure functions, another is closures, and another is immutability. These are all concepts that are very common to functional programming, and we're going to discuss them in a little while. So now that we understand what higher order function is, as you can see, it's not such a complicated concept.